All right, let's just jump right into this one. Back in 2022, we had this visitor from another star system just zip right through our cosmic neighborhood. And look, it wasn't just any old interstellar comet. This thing, 3I/Atlas, did something that absolutely baffled scientists. And it sparked some really wild theories. Why? Because it was pushing itself. And that little push, well, it immediately split people into two camps. On one side, you had some pretty high-profile folks asking, is this an alien engine? Are we looking at technology maneuvering through space? But on the other side, a much more subtle, and honestly, way more fascinating idea started to bubble up. What if this comet was powered by some kind of natural chemical engine? Something that works a lot like one of those reusable hand warmers. So yeah, let's break that down. Okay, so before we can even get to the wild theories, you've got to understand just how weird this comet was. I mean, the clues it left behind, they just didn't fit into any of the boxes we have. None of our standard models made sense. So this is where our story really kicks off. You have 3I/Atlas flying past the sun, and you can bet astronomers are watching it like a hawk. See, comets are supposed to be like cosmic clockwork, right? They should follow these super predictable paths that are all about the sun's massive gravity. But Atlas, well, it didn't play by the rules. It kind of veered off course, almost like something was giving it a little nudge. And this number right here, this is the heart of the whole mystery. Scientists measured this tiny but totally unmistakable non-gravitational acceleration, which, look, is just a fancy way of saying it had an extra push. It was this continuous, gentle thrust. We're talking about 2/100,000ths of a meter per second squared. That just couldn't be explained by the sun's gravity. Something else was actively pushing this thing. But it gets weirder. The mystery actually deepens, because it wasn't just about the veer. When scientists pointed their telescopes at it and analyzed the gas streaming off the comet, they found two more really strange clues. First up, they found nickel. Okay, cool. But where was the iron? Nickel and iron are usually partners in crime in cosmic chemistry, but the iron was just gone. Bizarre. And second, the comet was basically spewing out carbon dioxide, not water. And that's a big deal, because water is like the signature gas for most comets we know about. So the big question became, what in the world could explain all three of these things at once? All right, to even start cracking this case, we have to think about something you might actually have in a drawer at home. We're going to introduce this idea of a natural engine, but we use a really simple analogy to get us there. You know those reusable hand warmers? Okay, the key word here is metastability. Now, what is that? Well, you can think of it like a state of matter that's basically a coiled spring. It looks stable, it can just sit there for ages, but underneath it's storing a ton of energy. And if you give it just the right little nudge, boom, it could release all that energy in a flash. The best way to picture it is hot ice. Something that should have frozen or changed state, but for some reason it hasn't, at least not yet. So let's walk through how this actually works with a hand warmer, because it breaks down this abstract idea perfectly. Step 1, you store the energy. Inside that hand warmer, there's a liquid that's super cooled. That means it's actually colder than its own freezing point, but it's been tricked into staying liquid. That is our metastable state. Step 2, you need a trigger. That little click you make with the metal disc inside, that's the activation energy. And then step 3, all that stored energy gets released. The liquid instantly crystallizes, and all that potential energy comes rushing out as heat. So the big question becomes, could a comet, 3I/Atlas, have something just like this built right into its own chemistry? All right, so could this same principle actually apply to a comet? Is it possible that those weird clues it left behind were actually the recipe for a cosmic version of this hand warmer, like a natural chemical spring-loaded and ready to go? And this is where it gets really cool. Those bizarre chemical clues we talked about, the nickel with no iron, all that carbon monoxide and carbon dioxide, they weren't just random bits of data. No way. They might just be the ingredients list for our chemical engine. In fact, they point directly to some very specific nickel-based compounds that, get this, are known to be metastable. And here are our prime suspects. Scientists honed in on two main candidates. First, you've got nickel carbonyl. It stores a pretty good amount of energy, about 0.94 megajoules per kilogram, and when it breaks down, it releases carbon monoxide. Then there's nickel carbonate. This one's even more potent, storing about 1.6 megajoules per kilogram, and it releases, you guessed it, carbon dioxide. Are you seeing the connection here? These materials produce the exact gases that we saw coming off the comet. It's a perfect match. Okay, I know what you're thinking. How do you go from some tiny chemical reaction on a molecular level to a force that's big enough to push an entire comet through space? That's a huge leap, right? Well, let's connect those dots. Yeah, the source material actually explains this perfectly. It's not one single giant explosion. It's more of a cascade. As the comet gets closer to the sun and starts to warm up, that heat starts triggering these little metastable pockets. They start to pop, releasing gas. And all that gas starts to build up pressure inside the comet's crust. And, well, that pressure's gotta go somewhere, right? So here's the key thing to visualize. Imagine that snap from the hand warmer, but instead of one snap, it's happening millions of times on a massive scale. A comet isn't a perfect sphere. It's a messy, fractured chunk of ice and rock. So as the sun heats it up, countless tiny chemical pockets start popping, one after another, releasing their gas. All that gas funnels into the existing cracks and fractures in the ice, and when it finally bursts out, it forms these focused jets. That is the engine. That's the push. So the next logical question is, how much of this special fuel would you actually need? Well, physicists ran the numbers, and to get that push they observed, their model suggests that about 21% of the comet's total mass would have to be this reactive, metastable material. Now I know 21% might sound like a lot, but think of it kind of like the dense core of a planet. It's totally plausible that a comet from a whole other star system could have formed with a core super rich in these specific compounds, making up about a fifth of its entire weight. All right, let's pull all the pieces of this incredible puzzle together. When you look at all the evidence, do we really need to invoke an alien spacecraft to explain what 3I/Atlas was doing? Or has nature itself given us a much more elegant and, frankly, a much cooler answer? I mean, this whole theory of a metastable material acting just like the stuff in our hand warmer, it just provides such a beautifully complete explanation. It explains the veer, that's from the jets of gas. It explains the weird nickel without iron signature, because nickel just happens to be perfect for forming these kinds of energetic compounds. And it totally explains why the gas was rich in CO₂. That's just the exhaust. It all just clicks into place using physics and chemistry we already know. No aliens required. Now, we gotta be good scientists here and put on the brakes for just a second. This is an extremely compelling theory, but it is not yet a proven fact. The whole hand warmer thing, the SAT-like material, that's a powerful analogy for the mechanism, that quick release of stored energy. It's not meant to be a literal chemical description. There's still big question marks here, like the exact chemistry, the true shape of the jets, even the comet's total mass. But that's the cool part. This is science happening in real time. It's a leading hypothesis that just fits the clues so well. And that just leaves us with one last really fascinating thought to chew on. 3I/Atlas is gone now. It's already left our solar system. It was this fleeting visitor that came and taught us something totally new. But it really makes you wonder, doesn't it? If this one comet could build its own little natural engine out of some pretty basic chemistry, what other strange self-powered objects are hiding out there, sailing through the vast darkness between the stars?